Hey, welcome back everyone. We're going to look at task 2.3, and it's looking at something called the perfect square, which is a method that we use to work with quadratic equations. They're doing it from a visual standpoint, and the assumption is that all of these quilts are squares. So the side length, the base, is the same as the height, and you can express it as the area of x. This is the simplest one, would be x squared. Okay, so let's take a look at that. So if we look at x plus 3 squared, that's what you see here. We recognize x is the length here, 1 and 1 are the lengths there, and then x would be the length of that segment, 1 and 1. So to find the area of x, we add up. One way is to add up each of these. So x times x is x squared, x times 1 is x. So these are all x. So we've got x squared plus we got 6x. And then if we count these, 1, 2, 3, 4, 5, 6, 7, 8, 9, there are also 9. The other way to do area is base times height. And if we look at the base and the height, we can see that both of these are x plus 3. And that is a perfect square. You can also write it x plus 3 squared. Perfect square. One of the other problems is where they can't read the third term here, like x squared plus 4x, and you're trying to use a diagram or model to figure out what that term is so that you're sure it's a perfect square. So in other words, the base and the height should be the same. Well, here's what we have so far. This area is x squared. 1 times x is x. 1 times x is x. And then if you look at this, you're going to be able to break this 1, 2, 3, 4 into 4 separate squares that are 1 by 1s. So the third term would be 4, and x plus 2 squared, because it's x plus 2 times x plus 2, gives us a perfect square. Well, what if, then the question is, what's the relationship if you use x squared plus bx plus c? How are b related? And one of the things you hopefully came across is if I take my middle term and I half it, because I'm adding it together to get the middle term, and then I square it, I get my c term. Okay, so for example here, my middle term is 4. So if you did 4 divided by 2 is 2, and 2 squared is equal to 4. And that was my c term there. This other one, if you take the middle term 6 and you divide it by 2, you get 3, and 3 squared is equal to 9. That gives you the third term, and it's because when you expand it, you're multiplying 3 times 3. But does it work if you have a negative? So in this one, you can imagine you're subtracting 1 from both sides, right? So you're going to have x minus 1 times x minus 1 is the area, which is the same as x minus 1 squared. Okay, that's base times height, but does the model show that? Does it work? Well, we started, before we took away the this layer and this layer, we started with x squared. And then we took away, right here, we take away negative 1 times x, and over here we took away negative 1 times x. But we had a problem because we took away this last piece twice, so we have to add that back in because you can't subtract it twice. So we're going to say plus 1. It's a 1 by 1. And so this shows us x squared minus 2x plus 1 is a perfect square, and that works. Okay, what about if b is an odd number? So looking here, ax squared plus bx is c. if b is odd, would b divided by 2 squared equal the c term? Well, a little tougher on the modeling, right? Let's say you have, let's say your area is x squared plus 5x, so that's odd. So you have x squared, 1 times x, 1 times x, and 1 times x. This is going to be a problem when you try and model it this way. 1, 2, 3, 4, 5, 6, because what you notice is this side and this side are different lengths. So this model is not a perfect square. Okay, and that's because of the side lengths here. But what if you did a little differently here? What if you split it 1, 2, 1, 2, and then a half and a half? Because if we're looking at half of the b term is 5 halves, and then if we square that, we get 25 fourths, which is really 6 1/4. So does it work with this model? Let's just continue these down a bit so we can try it. Okay. All right, so I've got x squared, I've got x, 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 and then I've got half of x. And I've got half of x. So far we have x squared plus 5x. And then 1, 2, 3, 4, and then a half, a half, a half, and a half. And then this, remember this one right here is actually a fourth. So if we add those up, we actually get x squared plus 1, 2, 3, 4, 4 1/2 plus a half is 5x. 1, 2, 3, 4 plus a half, that's 5, 6 1/4.